Welcome to all in this new lecture. So here up to here we studied in this unit permutation, combinations and binomial theorem. So now that is the last topic is inclusion exclusion principle. So what is that? Let's see here. In this inclusion exclusion principle, we have the two sets A and B, and that are the finite sets. So A union B and A intersection B are also the finite if our sets are finite. And number of A union B, or you can say the cardinality of A union B, that is equal to the sum of the separately numbers number of A plus number of B, and this is called the inclusion. And subtract number of A intersection B, this is exclusion, right? Why? Because these elements are counted twice. So this is our the inclusion exclusion principle. So one corollary is there: if our sets are three sets, finite sets A, B and C, then A union B union C is finite, and we can say that we can calculate the number of A union B union C, that is number of A plus number of B plus number of C. Now we subtract number of both the combinations of AB, BC and AC. So that is number of A intersection B, subtracting number of A intersection C and subtracting number of B intersection C. Now addition of number of all these three, common point of all these three, that is A intersection B intersection C. So this is our the inclusion exclusion principle. Clear? Okay, so now let's take the examples here. So for our first example, suppose a list A contains the 30 students in a mathematics class, and a list B contains the 35 students in an English class, and suppose there are 20 names on both lists. So find the number of students. First of all, in the first part, we calculate only in list A how many students only in list A, and how many students only in list B, and how many students in both of the lists, and last one is in exactly one list, right? So first, in the A part, we have the total in list A we have the 30 students, right? And here we have to calculate only the students in list A, and here we see that there are 20 names both lists. So A students, list A students and B students both name in 20 also, so 20 names are both in list. So here we have A and B are both, and here we calculate only the list of A. So what we do, we subtract 30 out of total A list students, 30 minus 20. So here when we subtract 30 minus 20, so we get the 10 names, and that are is only in the list A. Clear? Okay, so now in the B part, we calculate the only in list B. So how many students in list B only? That is 35 students, and both A and B list students are 20. So we subtract 35 minus 20, then we get 15, and these are 15 students are only that is in list B. Okay. Now next one is both the lists. So how many students in both the list? So here actually in list here is also here, so what we calculate here, if we this and this, so we calculate here number of A union B, because after calculating the number of A union B, we get that the students that are both lists, means list A, list B, list A intersection B is both. So here we use the inclusion exclusion principle. So that is number of A union B is equal to number of A plus number of B minus number of A intersection B. And we know that number of A is 30 students, number of B is 35 students, and in both lists we have the 20 students. So when we calculate this is 45. So we can say that 45 students are in both the lists. Now next one is how many students in exactly one list? Exactly one list, right? So what you do here, you see that when we calculate in first part A and part B, 10 students are only in list A and 15 students are only in list B. So here we have to find the exactly in one list. So how many students? 10 students in list A, 15 students in list B. So 10 plus 15 total we have the 25 students are there, which has only in list 1, right? Maybe A or maybe B. So it is also called the number of A direct sum of B. So that is 25. Clear this is? Okay. So now you can express this also by the Venn diagram. By the Venn diagram, we see that these are the 30 students that is in list A and 35 students was in list B. So and how many students that are common parts? So this is the common area of A and B, that is given the 20 students that is in A and B. Clear? So here you can calculate that in the remaining part. This is the remaining part of this. So here how many students in only list A? You have to subtract 30 minus 20, so you will get the 10 students that is only in list A. And when we see the B, total students in B is 35 and the common part is 20. So when we subtract 35 minus 25, so remaining 15 students that is are only in B. Clear? So that is by the Venn diagram we can represent it like that. Now the another example, each student in liberal arts at some college has a mathematics requirement A and a science requirement B. So a poll of 140 students shows that 60 completed A, 45 completed B, 20 completed both A and B. So find the number of students who have completed. First one is at least one of A and B, exactly one of A or B, and third one is neither A nor B. So let's do it. So first of all we write that what we have from the question. So here we have the number of A, means we have the A completed the requirement, that is 60. Total we have the 60 students. So number of A is 60, number of B is 45, and number of, this is both 20 are in both A and B. So number of A intersection B, that is 20 is given. And 140 students, what is 140 students? 140 students is total students we have. So we can represent it U, that is universal set. So number of universal set, that is 140. It means that we have the total 140 students, right? So now what we calculate here in the first part, we need to calculate at least one of A and B. So what is the meaning of at least one of A and B? So what you do here, at least one, if you have suppose at least, so at least it means you have to find the union, right? So here you calculate at least one of A and B, so it means that you have to calculate the A union B. So now what's the inclusion exclusion principle are? That is an A union B is equal to number of A plus number of B minus number of A intersection B. So now we have the number of A, that is 60, number of B is 45, and number of A intersection B is 20. So when we calculate it, it will give the 85. So we have the 85, at least 85 of students of A and B. Okay, so now in the second part, exactly one of A or B, exactly one of A or B. So what is what here we have? We have that 20 both in A intersection B. So number of A intersection B is 20 here. Now exactly one of A and B, like the last example, exactly in A, how many students are in only in A? So we have to subtract total. In A we have the A 60, so 60 minus we have take subtract the which in both A and B. So we get that exactly in A how many students we have, right? So 60 minus 20, that is 40 have the completed A but not in B, right? So you can also represent it by symbolically number of A slash B, that is 40. So similarly in B, we have the in B is 45. So 45 minus subtract the common 20, so we will get the 25. So that is completely B but not A. So we can represent it by number of B slash A, it is 25. So now what we have to calculate exactly one of A or B, so maybe in or in, so we have to add these. So number of A direct sum B, so that is 40 plus 25, that is 65. So in which here actually we calculate that how many students in only in A or only in B. Okay, so now in the third part we calculate neither A nor B. How many students are there which have not the A, not the B? So it means that what you calculate here, you need to calculate that number of A complement intersection of B complements, means A complements neither in A and B complement neither in B. So in complement intersection B complement, and you know that we can write this A union B complement. It A complement intersection B complement, we can write this A union B whole complement. And we know that how can we calculate A union B? So that is already we calculate that N A union B, that is 85. So how can we calculate the complement? So if we subtract from the universal set this set, so we get the complement. So now n universal set, number of universal set minus number of A union B, so we get the number of A union B complement, so that is 55. It's clear? I think it's easy and to clear everyone. So let's see here how to we can see this by the Venn diagram. So here we have the common both A and B, we have the 20 students are here, and in A we have the 40 students, and in B we was the 25 students. So from here we calculate that how many in B, so we calculate that 40 minus 20. So actually okay, so total, in total A we have the 60 elements, in total B how many elements, we have the 45 elements. So remaining this part only A we have the 40 students, and remaining in B, only in B set we have the 25 students, right? So out total 60 we can subtract 20, so we get the 40, and in this total 45 we subtract 20, so we'll get the 25. Okay, so now to find the complement, so for the complement, how many complement means this is whole are the universal set. So if we subtract this from whole universal set of this complete one, so this is A union B, right? So when we subtract it, so we will get this. So this is our the 55, which are already calculated in our question. So by the Venn diagram we can represent it like that. Clear? Okay, so now let's take another example. Here, in a survey of 120 pupils, it was found that 65 read Newsweek magazine, 20 read both Newsweek and Time, 45 read Time, 25 read both Newsweek and Fortune, 42 read Fortune, 15 read both Time and Fortune, 8 read all three magazines, right? So here what you calculate, find the number of people who read at least one of the three magazines. Second one, fill the correct number of people in each of the 8 regions of the Venn diagram. So in figure A, actually that is given that where N, T and F denote the pupils who read Newsweek, Time and Fortune. So find next is find the number of people who read exactly one magazine. So actually here we have the three sets A, B and C. So what is the number means, we have here we have the Newsweek, Time and Fortune. So like the three sets we have here, and what is given in the question. So first of all, first you write what is given in the question, right? So what is given in the question, number of read only Newsweek magazine, that is number of N. So number of N is we have 65 and 25 read time. So number of T is 45. Sorry, 45 read time. So number of T is 45 and 42 read fortune. So number of F is 42. Now take the common part Newsweek and Times. So how many reads Newsweek and Time means the N intersection T, that is 20. So number of N intersection T, it is 20 and 25 read both Newsweek and Fortune. So number of N intersection F, it is 25 and 15 read both Time and Fortune. So that is number of T intersection F, it is 15 and 8 read all three magazines. All three magazines means Newsweek, Time and Fortune all. So it is A intersection B intersection C. So the number of N intersection T intersection F, it is given that at. So all these things we have given in the question. So now what we ask here, we want to find the at least one of three magazines. So I told you that at least means we find the union. So all three we have to find the at least one of three. So it means we have to calculate number of N union T union F, and we use here obviously the inclusion exclusion principle to solve this. So that is n number of N union T union F, that is number of N plus number of T plus number of F minus of number of N intersection T, number of N intersection F, number of T intersection F plus number of all of the common N intersection T intersection F. So now we have all these values, we put here all these values and we'll get that 18. It means that we have the at least 100 students are there which read all three magazines, at least all one of the three magazines. Okay, so in the second part, it is denoted are the Newsweek, Time, and Fortune. So, and it is given in the question that 8 is the common part, and this is total N, this is total T, this is total F. So, what is the second part? When we have to find that 8 read all three magazines. So we can say that by the Venn diagram, this is the common part. So in this common part, we have the total. So all three, that is 8. And after that, 20 minus 8, that is 12. So 12 means Newsweek and Time, but not all three magazines. So how many which has only read the Newsweek and the Time? So Newsweek and Time, that is are the this portion. So that is only 12 read is this. If we subtract 20 minus 8, so 20, that is both N and T, but we have to subtract that. This is not include F, so only NFF. So we can calculate it, 20 minus 8, then we'll get the 12. Next one is we have to find the Newsweek and Fortune, but not all three. So Newsweek and Fortune. So we have to subtract this common part 8 from the number of and Newsweek and Fortune. So that is 25 minus 8. So we get the 17 here. Now next we calculate that read Time and Fortune, but not the common. So we have to subtract 15 minus 8. So we'll get the 7, that are read only the Team and the Fortune. Now, next 28, we have the read only the Newsweek. So, how many only read the Newsweek? So, total out of total 65, we have to subtract 12 minus 8 minus 17. So, we will get this 28. So, that is only 28 are there which has read the Newsweek. Next one is which has read only Time. So we have to subtract out of 45 12 minus 8 minus 7. So we will get the 18. And similarly, we find the read only Fortune. So we have to subtract out of 42 17 minus 8 minus 7. So we will get the 10. Now, no magazine. Whose are there which is read no magazine? So this is all are the total magazine reading area. So out of this is our the universal set. So out of whole, if we subtract all these, so we will get our the that pupil who read not magazine at all. So total we have the 120. If we subtract 120 out of these 100, so we will get the 20. So 20 are their students which has read no magazine at all. Clear? So today's lecture is completed now. Thank you. Be happy, be healthy.